There is a gardener who wishes to have a very beautiful and colorful garden. So, he wants to calculate the areas of different plots of land in his garden for planting different types of flowering plants. So, he comes across this plot of land. It has length 50 units and breadth 10 units. So, what is the area of this plot? The area of this rectangular plot is length into breadth, which is 50 into 10, that is 500 units. Next, he comes across this plot of land. It has length 50 units, but the breadth of this plot is unknown. He doesn't have a measuring tape to calculate the breadth of this plot. So what does he do? He finds a rope and he marks the breadth of the plot on the rope and calls it X. Later, he can measure the length of the rope using a measuring tape and find the value of X. So, the length of this plot is 50 units and the breadth of this plot is an unknown and he calls it X. Area of the plot is length into breadth. So length is 50 into breadth is X. So 50 into X, we can write it as 50X. Here we have multiplied a constant with a variable. So 50 is a constant which is being multiplied with a variable X. It is 50X. Next, he comes across this plot of land. Its length is 3 times that of the earlier plot, but the breadth is same as that of the earlier plot. So he calls this breadth also X and length is 3 times 50. So length is 3 into 50, which is 150 units. And the breadth, what is the breadth? It is X units. So area of the plot is length into breadth, which is 150 into X, that is 150X. This is the area of this plot. Next, he comes across this plot of land. Its length is 50 units, but breadth is 3 times that of the earlier plot. So length is 50 units and breadth is 3 times X. We can call it 3X. 50 and 3X. Area of the plot is length into breadth, which is 50 into 3X. Now what is this 3X? This 3X is actually 3 into X. So 50 into 3 into X. 50 into 3 is 150. So this is 150 into X. And 150 into X is 150X. So the area of this plot is 150X. Now we see that these two plots have the same area. The area of this plot is 150X and the area of this plot is also 150X. Let us see if it holds visually as well. Now this part of this plot, it perfectly overlaps with this part of the plot. This part, it perfectly overlaps this part. And this part, it perfectly overlaps this part. So we see that 3 into 50 into X is the same as 50 into 3 into X. Hence, we can say that multiplication is commutative because 3 into 50 into X is the same as 50 into 3 into X, and multiplication is commutative. Next, he comes across this plot of land. The length of this plot is also unknown, and he calls this length as y. So he denotes it by a variable y, and breadth is x. What is the area of this plot? The area of this plot is length into breadth, which is y into x. Now, till now, we have multiplied a constant with a variable. Here, we have two variables, and we have to multiply these two variables. So, the area of this plot is y into x. And when we multiply two variables, it can be written as yx or xy. So, any of these can be used to represent the area of this plot. It can be yx or xy. And this is how we multiply two variables. So we have seen how we multiply expressions containing just one term, or how we multiply monomials. Let us see some examples. 6p into 7q. Now what is 6p? 6p is 6 into p into, what is 7q? 7q is 7 into q. So we have 6 into p into 7 into q. Now we take 6 and 7. What is 6 into 7? 6 sevens are 42 into p into q. So 42 into p into q. It can be written as 42 into pq. Pq are two variables which are being multiplied. So 42 into pq and a constant multiplied with pq. 42 into pq is 42 pq. So we see that when we have to multiply two monomials, we can first multiply the numeric parts together. That is the numeric part of this monomial and the numeric part of this monomial, which is 6 into 7, 42. Then we can multiply the algebraic parts together. That is the algebraic part of this monomial p and the algebraic part of this monomial q, which is pq. So it gives us 42 pq. Note that for multiplication, it is not necessary to have like terms. 6p and 7q are not like terms. In addition, we require like terms, but in multiplication, it is not necessary to have like terms. Now, in a similar manner, we can multiply any number of monomials. We can multiply 2, 3, 4, any number of monomials similarly. How? Multiply the numeric part of all the monomials and multiply the algebraic parts of all the monomials. So let us multiply these three monomials, which are the expressions containing just one terms, and see what we get. So what are the numeric parts? Negative 3 into 5 into 2. And the algebraic parts, AB into ABC into AC. Now what is this? Negative 3 into 5 into 2. Negative 3 into 5 is negative 15 into 2 is negative 30. So it is negative 30 into. Now let us consider the variables one by one. A. We have an A here, an A here, and an A here. So A into A into A. A is being multiplied 3 times. So it is A cubed. Again, let us consider B. So we have a B here and a B here. It is B into B. B is being multiplied 2 times. So b to the power 2, b square. What is left? C. C is also being multiplied 2 times. So we have C into C. So c to the power 2. So finally, we get our answer as negative 30 a cube b squared c squared. And this is how we multiply monomials. So let us solve a question now. 11x and 5y are two unlike terms. They can be added but not multiplied, or multiplied but not added, or added as well as multiplied, or neither added nor multiplied. So we have 11x and 5y. 11x and 5y. These are unlike terms. So we cannot add unlike terms. So they cannot be added. However, we can multiply unlike terms by multiplying their numeric parts and the algebraic parts. So they can be multiplied but not added.